In this video, we're going to talk about how to write numbers in scientific notation and how to take them out of scientific notation. It's a very easy process that we use in science to help us keep up, number one, with the number of significant figures that is necessary in the problem and writing an answer that is precise and accurate to that. And secondly, to keep from having to write such large numbers that would carry out decimal places up to 20 or 30 spaces. So in this video, I'm going to show you how to do that. It's a very easy process, just something I want to make sure that you guys have because it's a wonderful skill to have going forward. So if you had a number like 200, and I asked you to write this number in scientific notation, how you would do that is you would start with the decimal, and please note that the decimal is after the last zero here. When doing scientific notation, make sure that your decimal goes between the numbers 1 and 10. If it is less than 1 or greater than 10, it could not be correct according to scientific notation rules. So our decimal would need to go in between the 2 and the 0. So we should begin as writing this number as 2.0. Now, what we do from this step is we count the number of decimal places that it took us to get there. And so you're going to raise it to a power of 10 because each time you move the decimal, it's a power of 10. And so if we went to the left 2 times, you would have raised it to the second power. So it would be 2.0 times 10 to the second power. Now the reason why we had to put the decimal between the 2 and the 0 is because, like we said earlier, if the decimal was after the first 2, it was before the first 2, it would have been 0.2, which is less than 1. And if it was after the second, or the first 0, my apologies, it would be 20, which is greater than 10. So that would not have been acceptable. Let's do another. If we had 1,575, our decimal is after the 5. And so we know that we need to be moving the decimal between the numbers 1 and 5 because those are the numbers that are in between 1 and 10. So our decimal would be 1.575. Then we'd multiply it times 10, and then we would count the number of movements of the decimal, 1, 2, 3. And so we would raise it to the third power. Now, if you had a decimal number, if you had a number something like 0.015, let's say, this number is still treated the same way, except you would not have a positive exponent. You would have a negative exponent. But the first part of the number should be between 1 and 10. And so it's obvious that our decimal has to go between the numbers 1 and 5. So it would be 1.5 times 10. Now remember, since we moved the decimal to the right 2 places, this exponent has to be a negative value. So it would be 1.5 times 10 to the negative second. Let's do one more. If we had 0.00076, you would have had to move the decimal 1, 2, 3, 4 times to the right. So it would be 7.6 times 10 to the negative 4. And once again, the decimal went between 7 and 6 because if the decimal went after the 6, the number would have been 76, and that is too high. And if the decimal was in front of the 7, between the 0 and the 7, it would have been 0.7, and that is too low. That value is underneath 1. So that's how we put numbers into scientific notation. Let's learn how to take them out of scientific notation. If you were given a value of 2.75 times 10 to the third power, you would have to move the decimal. Typically what I like to do is do a couple of steps here. Is you would do 2.75 just like you saw the number. Now you have to account for the exponent of 3, and so you would move the decimal 1, 2, 3 times to the right, and you would add your 0. So your final answer here should be 2,750. You could also, we can do another one just to make sure that we drill this point home. And let's do 3 times 10 to the 0th power. Hopefully you guys know what 10 to the 0th power is. It's just 1, right? That's the same thing as 1. So 3 times 1 is 3. So it's the same principle there. Just wanted to throw a little trick at you. Now, if we had 4.67 times 10 to the negative second power, this time, since it is a negative exponent, you will not move the decimal to the right, you will move it to the left. So if you had 4.67, you would move that decimal 2 times to the left. And we know that this value should begin with a decimal because the exponent was negative. And so our final answer would have been 0.0467. Last one. Let's do another negative exponent just to make sure you guys understand which way to move the exponent. I'm sorry, the decimal. If we did 5.89 times 10 to the negative fifth, you would have 5.89, and you would move the decimal 1, 2, 3, 4, 5 times. And so you would fill that in with zeros, 0, 0, 0. So it would be a final answer of 0.00000589. Now you can kind of see why scientific notation is so helpful, is because we do not want to write garbage like this. We want to make sure that the answer is easy to write and time efficient. And so writing in scientific notation makes that answer look a lot cleaner than what we just wrote. Anyway, I hope this video helped you have a better understanding of scientific notation.